3.2 Limits a Visual Approach. So we're going to start with an informal definition. As we approach an x value, let's give it a value of b from the left and the right. If the y value approaches the same real number L, then L is considered to be the limit of the function as it approaches b. So the way we write this is lim x approaches b of f of x is equal to L. There are three cases that we may approach when we work with limits. The first case is I have a graph here, and as I continue along towards this b value, I am approaching L, some value, and my graph also exists at L. So f at b is going to be equal to L. The second case, as I approach b from the left and from the right, I approach this value of L, but my graph doesn't actually exist there. It's a hole. It actually exists somewhere else, which in this case is at t. The third case is similar to the second case where it doesn't exist. There's a hole at f at b. However, it doesn't exist anywhere else on the graph either. So it just doesn't exist for whatever that b case is. This is when we call it indeterminate. In this example, we are going to examine the graph in order to determine each of the following limits. So the first limit is asking us to find as x approaches 0. So what I'm going to do is I'm going to look at my graph and I'm going to see as my x values get closer to 0, what is my y value getting close to? And in this case, as x is approaching 0, my y value is getting close to positive 1. When I do this for my b, we are going to be approaching 3 instead. So as x approaches 3, I'm going to look at it and I'm approaching a y value of 0. For c, I'm going to be approaching a x value of -1. And as I do that, I'm going to approach a y value of 2. D, we are going to be approaching an x value of -2. Now this is where something a little weird happens. So as I approach -2, I'm getting close to 3 from the left-hand side, and from the right-hand side I'm also getting close to 3. It doesn't exist at 3 though, so this is actually that case 3 that we talked about before. Our limit is still 3, but it's important to note that this is actually indeterminate as well, because it doesn't actually exist in that space. This is an indeterminate limit. As we do e, we are approaching +2. +2 is the same as case 2. So as I approach +2, I'm getting really, really close to -2, and I'm getting really, really, really close to -2. However, it doesn't exist at -2. F at 2 is actually equal to 1. The limit is still -2, but it's important to note that f at 2 is going to be equal to +1. The last example that I have for you is the limit as x approaches -3. This is back to a case 1, so as I approach -3 from the left side, I'm getting close to 2. From the right side, I'm getting close to 2. So my value of the limit is going to be 2. One-sided limits. So I have a graph here of this function. It's a piecewise function with any x values less than 0 or equal to 0 following the -2x plus 1 equation, and anything greater than 0 has the equation of x plus 1. So as we approach 0 from the left-hand side, we are getting closer and closer and closer to y equals 1. However, as we approach from the right-hand side, we're getting closer to a y value of 3. We can actually write the difference between these using the different notations. So from the left-hand side, we're going to say that x approaches 0 with a superscript or an exponent script of a negative, and from the right-hand side is a positive. Now I like to think about this in terms of coming from the negative side of a number line and the positive side of the number line. It's just a little trick that I use to help me remember which side I'm coming from in order to write the proper things. The next thing we're going to talk about is limits that do not exist. So in order for the limit to exist, the limit as you approach b from either side must have the same real number. That is, as I approach from the negative and as I approach it from the positive, it has to equal the same number. So the example that we had above, where it approached positive 1 from the left and positive 3 from the right, would not have a limit that exists because those two numbers are not the same. Infinite limits. The graph on the right here has a vertical asymptote at x equals 2. So this here is a vertical asymptote. When we look at the graph, we can see that as we approach from the left-hand side, we are increasing without bound, or we're going to continue and continue until we get really, really close to infinity. Similarly, if we approach from the right-hand side, the same thing's going to happen. We're going to increase without bound, or we're going to get really close to positive infinity. So therefore, I can say that the limit as x approaches 2 of f of x is equal to infinity. Now, I know that I keep telling you that infinity does not exist, that it's a concept, so it's not a real number, but it's actually more accurate to describe the behavior of our graph in this way. So we're going to state that it does approach infinity as opposed to saying that it doesn't exist. The last graph that I have here has a limit that does not exist. The reason why it is because we do have this vertical asymptote at -2, but as I approach from the left-hand side, I'm going to go to negative infinity. And from the right-hand side, I'm going to be going to positive. And from the right-hand side, I'm going to be going to positive infinity. Those two numbers are not the same. Because positive infinity and negative infinity are two different numbers, we can state that the limit does not exist. Limits at infinity. We can also calculate limits as our x value approaches infinity. So we can calculate limit as we approach this way and see what happens as we get our x values to be bigger and bigger and bigger. The graph at the right has a horizontal asymptote at y equals 0. So we have a horizontal asymptote right here. You can see it extends just beyond our grid lines. So our y values are approaching a value of 0 as our x value approaches infinity. So as I continue on in this direction down this line, I'm going to get closer and closer and closer to infinity, but I'm not actually going to touch it. The same happens in the negative direction. So as I get closer and closer to a negative infinity, I'm going to get closer and closer and closer to 0. So then I can say that the limit as x approaches infinity of f of x is equal to 0. This will happen often if we have a horizontal asymptote. It'll approach whatever our asymptote is. But in most cases, or in many cases, the y value will actually approach infinity as x approaches infinity. So if we were to think about this as being a parabola or any other form of a line, as I continue, so let's draw just a really rough parabola here. As my x value is going to continue to get bigger, infinitely, my y value is going to get infinitely bigger as well. So that would be a case where my y value is also going to approach infinity. This last example, we are going to look at a bunch of situations and determine the values of each thing. So the first one is f at -6. So this is asking us, what is the value of our graph at -6? So if I go to -6 on my x values and move up my grid lines, I will see that my y value is going to be +7. I think that you guys are really good at determining the points on the graph, so I'm going to ask you to go over these and then we will check our answers once you get back. So the answers you should have gotten was that the value of f at 0 is 0. The value at f at 3 is going to be 1. Now this is kind of tricky because there's a hole in our original graph, but we need to look for the dot where it actually exists, which happens to be at 1. F at -4, we're again going to look for the filled in dot as to where it actually exists, and that's going to be at +3. E is probably the trickiest of these. F at -3 doesn't actually exist anywhere. So we have a hole in the graph where we think it might be, but it isn't denoted to be anywhere else. So we have an indeterminate value. As we move into F, we are going to be looking at limits. So the first one we're going to look at is the limit as we approach 1. And as we approach 1 from the left and the right-hand side, we are going to be approaching a y value of 1. With G, we are going to be looking at as we approach -5. So as we approach -5 from the left and the right-hand side, we're going to be looking at +5 as a value. Now, I'm sorry that this is jumping around a little bit. I think that you can handle H and I on your own, so I'm going to get you to pause the video and try it out and see how you do. All right, so for H, you should have gotten that as we approach 0, we are going to have an H or a Y value of 0. And for I, as we approach 3, we are getting close to 2. Now this can be a confusing one because it approaches 2 but exists at 1. Remember, we're looking for what does it approach. As we move into the next questions, you'll notice that they have the plus and the minus signs in those sort of exponent positions, asking us to look at it from the left and the right-hand side. So when I look at J, I'm looking at going to -4 from the positive side. So I'm going to be coming down this part of the graph towards -4. And as I move towards -4 from the positive side, I'm approaching a value of 1. K is asking us to do the exact same except for from the negative side. So we're going to approach -4, and as we do that, we're going to be coming to a value of 3. L is asking us to approach -4 in general. So that means I need to approach it from both sides. Now, we just finished doing this in J and K, and we got 1 and 3. Now, we know that because those are not the same numbers, the limit in this case does not exist because it would have to be approaching the same number in order for it to exist. As I look at M, it's going to ask me to approach 2 from the positive side. So as I approach 2 from the positive side, I'm going to be getting closer and closer to infinity. N is asking me to look at 2 from the negative side. So as I go from the negative side, I'm approaching infinity as well. O is asking me to approach 2 in general. So I need to look at it from both sides. And from both sides, I'm approaching infinity. So my answer is going to be infinity. Question P is asking me to approach -2 from the positive side. So -2 from the positive side is going to give me -infinity. Q asks me to approach -2 from the negative side. So as I come from the negative side, I'm going upwards towards positive infinity. And R asks me to look at -2 in general. So I'm approaching positive infinity and negative infinity. Those are two different numbers, so I can state that this does not exist. Now we often put DNE for does not exist. It's just a little bit of a shorter way to denote that. The last two questions here are S and T, and they're asking us to look at what happens as x approaches infinity. So as x approaches infinity in S, as we get closer and closer and closer this way, we are approaching +1, because you can see that there's a couple dashes here denoting that we have an asymptote. So as our x gets infinitely large, my y value is going to get closer and closer to 1. T is asking as we approach negative infinity. So as I approach negative infinity, I'm going to follow this line here, and it's going to continue to move up and up and up beyond our grid here, and it will actually approach positive infinity as it continues through.